Alright, so today we're going to get into lesson 10.5 and 10.6, which is going to take us into scientific notation. We're going to talk about how we can read scientific notation and write scientific notation. The biggest thing with scientific notation is understanding the lessons we did previous will lead us into this. We did 10.1 through 10.4 are all over exponent rules and all that. And those can be applied somewhat whenever it comes to scientific notation as well. So, first we need to know what scientific notation is. So, here's your definitions for this section, which is scientific notation and standard form. So, scientific notation is a number written as the product, remember product means multiplication, of a factor and a power of 10. The factor must be greater than or equal to 1 or less and less than 10. So, key part here, it's a product of a factor and a power of 10, and then that factor, whatever the factor is, it has to pretty much be between 1 and 10. Okay, it cannot be smaller or bigger than those numbers. And then standard form is just the normal way in which you write a number usually, and you'll see the difference, but there's scientific notation as a way to write a number, and then standard form is just a regular way you would write a number. So this is what scientific notation will look like, and it has each part labeled. So this is 8.3 times 10 to the negative 7th. So the factor in this is 8.3. The number here is your factor. Remember, that has to be between 1 and 10. And then the power of 10 has an integer exponent, meaning it can't have a decimal or fraction as an exponent. So here we have 10 is our power of 10, of course, and then we have an exponent of negative 7. Okay, so that is the way that your scientific notation will be written. Okay, so let's look at a couple examples of things they might ask us to do in this section. So here we have, it says, tell whether the number is written in scientific notation or not. Explain. So if you real quickly look at this, you'll say, yeah, they're both in scientific notation, but you have to be careful. So part A, 5.9 times 10 to the negative 6. So remember, scientific notation has a factor between 1 and, or greater than 1 and less than 10, and then a power of 10 with an integer as its exponent. Our factor here is 5.9. You ask yourself, is that between 1 and less than 10? Yes, it is. And then we have the power of 10. Remember, this is always times 10 to a power. It can't be times 9 to a power, times 12 to a power, times any other number but 10. It's 10, and then we have a power of 6, negative 6, and that works. So yes, this one is written in scientific notation because it meets the definition of scientific notation. And you can go ahead and explain that more, saying that this is between 1 and less than 10, and then this has a base power of 10 with an exponent. So the next one is 0.9 times 10 to the 8th. So this one here would not be written in scientific notation because 0.9 is not between 1 and less than 10. So this would not be in scientific notation, you say, because the factor is less than 1, but it has to be at least 1 or greater. So then we look at a couple more. Then we go on to writing numbers in standard form. So sometimes they might give you the scientific, and we'll do both ways, but sometimes they'll give you the scientific notation and ask you to write that number in standard form, which is the way you regularly write a number. So this says, when writing numbers in standard form, remember, if the exponent is negative, move the decimal point that many places to the left. And just the opposite, if the exponent is positive, move the decimal point that many places to the right. So very, very important to keep these straight with what you're doing. So think, if you have like a coordinate plane or a number line. If you have a number line, when you're going to the left, you're going down. You're going towards the negative number. So negative, you go left. Positive, you go right. Make sure you keep that straight for what you're doing. So negative, if you have a negative exponent in scientific notation, you're going left that many spots for your decimal point. And just the opposite, if you have a positive exponent, you have to go right that many points to move your decimal. So as long as you can keep those two separated and understand which is which, this should be fairly simple for you. So let's look at each of these. So part A says, write 3.22 times 10 to the negative fourth in standard form. So first, the way you start this is you just write down your factor. So our factor is 3.22. So again, you pay attention. The biggest part of writing a scientific notation in standard form is paying attention to that exponent. So our exponent here is negative 4. So if we have an exponent of negative 4, remember, if it's negative, you take that decimal point, which is here, that many spots to the left if it's negative. So what I'll do is I'm going to go 4 spots to the left. So I'm going to go 1, 2, 3, 4. And here is my new decimal point. And then remember, if you have empty spaces, you just fill those in with zeros. So this would be my answer. My answer would be 3.22 times 10 to the negative fourth in standard form would be 0.000322. So there is your answer. And could be wrong on this, but let me check. If you plug that in your calculator, let's see, 3.22 times 10 to the negative fourth, and you'll get that exact answer, 0.000322. Unfortunately with this, sometimes you can't always rely on the calculator, because if you get too big of an exponent, like if you get up into 9, 10, 11, 12, and so on, it won't show up on your calculator in standard form. So you have to make sure you know how to move those decimal points. Okay, so next one, we have 7.9. So that's my factor, that's what I start with. 7.9 times 10 to the fifth in standard form. So again, we look at our exponent is positive. So if you have a positive exponent, you move your decimal point that many spaces to the right. So positive right, negative left. So I'm going to take this 7.9, the decimal point in it, and go 1, 2, 3, 4, 5. So now my decimal's all the way over there. So here, I fill in my zeros, is my new number. So 79000. And remember, every 3 you can put a comma to understand what that number is. So this here would be labeled as 790,000. So that is how you write 7.9 times 10 to the fifth in standard form. And again, this one has a low enough exponent that you can plug that in to your calculator and it will give you that. But again, you don't want to rely on that, because when you get into the larger exponents, it will not show up on the calculator. So you need to know how to actually move it, or how to move that decimal point correctly. Okay, so these two, I want you to try on your own. So you can pause the video and try them. Hopefully you pause the video and try it on your own. So here we have part A, write 2.75 times 10 to the negative third in standard form. So again, we start with our factor and we pay attention to the exponent. The exponent here is negative. So negative exponent tells me to move that many spots to the left. Negative left. So 1, 2, 3. Fill in my empty spots with zeros. So my final answer would be 0.00275. And you can put a 0 out in front if you want to. It really doesn't make a difference. But there's your final answer, 0.00275. Let me do the next one, 6.38. 6.38 times 10 to the seventh in standard form. So again, positive exponent here, that means I need to move my decimal point to the right. So 6.38 to the right 7 times. 1, 2, 3, 4, 5, 6, 7. So this is going to be a very large number. I'm going to rewrite that. 6380000. So if you put the commas in the correct spot, you'll see that this number is 63,800,000. So a very large number, and that is why they use scientific notation is used, It's an easier way to write really big or really small numbers, because you got to think, if you get into like 10, 20, 40, or sorry, 10, 20, 30, 40, 50, those really large exponents or really small exponents, if they're negative, it's going to make these numbers very, very long. So it makes it much easier to write it in scientific notation. All right, so now let's look at writing standard. Now we're going the other way. Write standard form numbers in scientific notation. So we're doing, instead, they give us a standard form, regular number, and we have to make it scientific notation. 2 steps to doing this. 1, move the decimal point so it is located to the right of the leading non-zero digit. This confuses students all the time, and I want to make sure I emphasize this right here. Leading, located to the right, so on the right side of the leading, meaning the number in front, non-zero digit. So it can't be 0. Any other number but 0, that is your leading digit, and you want to be the decimal point to be on the right of it. And then it says count the number of places you moved the decimal point. This will be your exponent on the power of 10. Okay? And again, you guys be careful, and the next slide will give you a better idea of how to understand this, but you got to be careful about which, if it's going to be positive or negative. So this will give you a better hint for how to pay attention to that. So if the number in standard form is greater than or equal to 10, you use a positive exponent. So if you have a really big number, you're going to use a positive exponent. Okay? And if you have a really small number, if the number in standard form is between 0 and 1, use a negative exponent. So you count your number, or you move your decimal point, count how many spaces you move, but then you pay attention and say, okay, was that a really big number I had or a really small number? And that is going to tell you whether you use a positive or negative exponent. On this, you cannot just base it off if you're moving left or right, because that is not, it's actually going to be the opposite. So only when you're going from scientific to standard do you do the left or right. But now when you're going the other way, standard to scientific, you have to pay attention to how big or small that number was. Okay, so let's look at an example. This says Google purchased YouTube for $1,650 million. Write this number in scientific notation. So 165,000,000. And remember, if you have a number like this, your decimal point is at the end. Okay, so there's where my decimal point is. So think about what the step 1 was. You have to move that decimal point behind, to the right of, the leading non-zero digit. So I look in the front. The leading non-zero digit is 1. That's the front number that's not 0. So I need to move my decimal point to the right of it, which will be here. So I'm going to take this all the way over there. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So I move that 9 spots to get there. So my factor, and remember, your factor, this will tell you if you did it right or not, or if you moved it to the correct spot or not. Your factor is now 1.65. Okay, all those zeros don't matter now. So 1.65 is my factor. Remember, for a factor in scientific notation, it has to be between 1 and less than 10. You ask yourself, is this between 1 and less than 10? Yes, it is. So that's why it's important. Like if you were to move it to here, for example, that would have been 16.5, and that would not have worked. So you have to make sure you move it to the correct spot. So 1.65 times 10, because we have a power of 10, and then remember, your exponent is how many spots you moved. I moved 9 spots, but you have to think about if that's going to be positive or negative. So remember the last slide said if you have a very large number, a number bigger than 10, it's positive, but if you have a number between 0 and 1, it's negative. So as you can see here, 1,650,000,000 is much larger than 10. It's a very big number. So since it's a number bigger than 10, this 9 is positive. So that stays positive in this case. So 1.65 times 10 to the 9th would be your final answer. I know there's a lot to remember with that, but hopefully you understood those steps. So let's look at another one to give us some more ideas of what's going on. This says the 2004 Indonesian earthquake slowed the rotation of Earth, making the length of a day 0.0000268 seconds shorter. Write this number in scientific notation. So, my number is 0.0000268. So, I need to write this in scientific notation. So remember, you have to move your decimal to the right of the leading non-zero digit. So, all of these are 0. So I find the first digit that's not 0. It's 2. So, that means I have to move it to the right of that. So, that would be right there. So I'm moving this decimal point to here. So that would be 1, 2, 3, 4, 5, 6 to get to there. So once I move it to there, my new factor would be 2.68. So that is my factor, 2.68. That's between 1 and 10, so that tells me I moved it correctly. So I moved it, again, 1, 2, 3, 4, 5, 6 spots. So times 10, and then an exponent of 6. But remember, you have to pay attention if it's positive or negative. So if it's positive, it will be a number that you started with will be bigger than 10. But if it's a number you started with for it to be a negative exponent, it'll be between 0 and 1. So as you can see, 0.0000268 is a very small number. That is between 0 and 1. So, since it's between 0 and 1, I have a negative exponent. So, 2.68 times 10 to the negative 6 would be your answer. You have to make sure you pay attention to if it will be a positive or negative exponent. It should be pretty easy because if it's a very, very small number, it's a negative exponent. If it's a very, very big number, it's a positive exponent. So negative exponent for very small, positive exponent for very big. So hopefully that made sense. I know there was a lot in that. You can go back and watch this again to break down the different things you need to pay attention to. A lot of different tips to work these out. But as long as you remember the different tips and tricks, this should be fairly easy, because what we're going to do is going to take, in 10.7, is going to take the information with scientific notation and pretty much multiply, divide, do different things with scientific notation, and we're going to show how that is done. So, thanks for watching.